by a quick show of hands here, who here has more than a decade working in the IT sector? Most of you. So, I know you do. So for the one people who've had their hands up, maybe some of you remember that roughly 11 years ago, there was some guy in the book, PayPal Hacks, who proposed to his wife in the acknowledgement. That's him. He's semi-famous for that. Did she say yes?
She said yes.
Yeah. So please welcome developer advocate of Redis Labs, Dave Nielsen. Thank you very much.
All right, well, very happy to be here, even if it's a little wet, from California, where we don't get any rain, apparently. And if we could just figure out some way to hack a little downhill waterway to California, I think we'd make millions. Yeah, well, we'll figure that out. Maybe tonight we'll figure that out. I'm a big fan of New York. What I love about New York is the public transportation. I know that doesn't sound like what you would normally think, but I do love that because, and we have a little bit of it in San Francisco, but see, I come from LA, and Los Angeles is just not really the public transportation mecca of the world. It could be, but it's so cool because you get to kind of rub elbows with like all sorts of people that you don't necessarily work with or live with. So I don't know. I think it's really cool. You meet all sorts of people. You smile. I don't know if do you guys smile on the subway? No. I must be an easy target because people smile back to me because they're like, tourists. They'll smile. I guess if you live here, you don't so much. But no, I really enjoy that. It's like you can tell a lot about a city by how good its transportation system is. There's actually a pretty good formula out there that determines the economic viability of a country based on the transportation. So, way to go, New York. I'm here, of course, to talk about Redis, but I have a pretty extensive background with all cloud technologies. So I'd love to share some of that as well. We don't have to stick directly on target, but I do also want to keep things moving. So I promise not to go too far afield. But just a couple things. First of all, I want to tell you a little bit of a build-up to this before we get going. You got my information here. You know what the topic is. We're going to talk about Redis a lot. And here's the giveaway. A couple things also. We have if you want to learn a lot about Redis, there's a book written by Dr. Josiah Carlson, which you can get on our website. It's for free. We paid the license fee to be able to give it away for free on the website. So just go to redislabs.com/ebook and you can get a lot of great information there. We're giving away t-shirts. And okay, so I've been around for a while. These weren't gray when I started. And I just want to tell you a little bit of sort of a trajectory. When you look at things from hindsight, you can kind of start telling where things might be going, right? And I know that a lot of you won't remember this, but when the web first came out, people were like, why on earth would I ever put information out on the internet where somebody might see it? That was actually part of the conversation a long time ago. Then, over time, of course, we saw people put personal information, YouTube, all that kind of stuff. But from a technology perspective, all of a sudden there were these web APIs. And I was one of the first, if not the first, web API evangelist. I started a web API user group in 2001. Wow. I was hired by PayPal to be their API evangelist in 2003. This is back when there really weren't API evangelists. And it was interesting because back then when you talked to folks and you said, hey, developer, you should go use an API, they would say, are you freaking nuts? I'm having a hard enough time keeping my own website out. I don't website on. I don't want to have somebody else's API crash my website, so I'm not doing that. And of course, I was at PayPal, and I'm like, well, how about if you make a little bit of money on the payment transaction, right? Okay, maybe. But it was early days, and folks were really freaked out about using APIs because it might crash their website. Of course, eventually that changed. Around 2006, mashups came in, and people started using mashups. And then I was into cloud. Around 2006 is when Amazon EC2 came into beta. I was in a beta program, and I was into cloud. I'm like, hey, I know I was telling you to use those APIs before. Now take your entire code, all of your application code, and put it on that virtual machine that might disappear at any minute. And people were like, that's crazy. Nobody's ever going to do that. I'm like, okay, well, we know what happened with APIs. Now you're all using them. You're going to be using this stuff too. Of course, they did. And now we've got pretty popular clouds out there where people are pushing their code onto virtual machines that might disappear at any minute. Crazy, but they're doing it, right? So fast forward a little bit. By the way, I ended up organizing some events called Cloud Camp, which we did a ton of all over the world. It was actually an unconference style event where we would all get together and let people, attendees, actually propose topics and then have discussions. And we did about 350 of these in over 100 cities. It was quite an adventure. I talked a lot of cloud, a little too much. Some folks told me, for me, it was kind of like Groundhog's Day, I'm like reliving the same event over and over and over again. But I did get to learn a lot about cloud. So just as we were telling folks, put your code up in the virtual machine that might disappear at any minute, now I'm telling folks, put your priceless data in memory that might disappear at any minute. And you know what? They're doing it. So, I just can't sit and talk about the things of the past. I want to talk about the future. And the future is now, and it is putting the important stuff, the really important stuff, in memory in a database. Why? Because the important stuff is what people want, and they want it now. So you got to do that. You got to put it in memory. So that's what Redis is all about. It's about taking your information, putting it in memory, and interacting with other websites, people, other systems as fast as physically possible. So that's what I'm here to talk about. How many of you have actually used Redis in some way, shape, or form? Quite a few hands, cool, all right. How many of you have actually deployed Redis? Awesome, okay. All right, you guys are the ones who've been there. So for those of you who haven't been there, Redis is incredibly popular. It's not that everyone's heard about it, but it is growing extremely fast. It's also an extremely fast database. And of course, you can always bend benchmarks, but if you just did your average benchmark test, Redis would probably come out #1. It is extremely fast. Part of that has to do with the fact that it's in memory, but also that has to do with the fact that it is purposely focused on being as fast as possible compared to other databases that sometimes have other goals, like being easy to get started with. Okay. The funny thing is, Redis is also easy to get started with, but it's a little bit different because it's in memory. So, but it is extremely popular. It's very, according to G2 Crowd, I don't know who they are, but they had a satisfaction survey, and Redis came out #1. It's extremely fast growing overall, #1, fastest NoSQL database in growth. I know this personally, if you do any container demos or if you get involved in containers, Redis is #1 in containers by like far. Okay, it's very popular in containers. And it's a very popular tool. Out of all developer tools, apparently it's like #12 in popularity. So developers like Redis. So this is all good news. So let's keep going here. All right. So Redis Labs, company started in 2011, primarily focused on hosting Redis as a service for others. We are now the official sponsor of the Redis project. We do not own the open source project, but we were sponsoring it. Okay, it's owned technically by Salvatore Sanfilippo, which is also licensed incredibly liberally. So it's a BSD license, which basically means any of you can take it and do whatever you want with it. So it's incredibly free and open source. And we actually hired Salvatore. We pay him as an employee. However, he primarily works on the open source work that everyone gets to use. So I do have to go a little bit into detail about the company. I want you to know what we do. It's actually very valuable. If you came here to learn about Redis, then you probably want to know what ways you can use Redis. And we are a very popular Redis provider. So we have 2 offerings. The first one that we started with was Redis Cloud. Redis Cloud is a very popular Redis as a service offering. We have over 40,000 customers, of which over 5,400 actually pay us, which is nice. And we've deployed lots and lots of Redis databases, so over 120,000 deployments of production databases over the last 3 years. And when Amazon instances go away, which you know they do, we have no problem with that. We've never lost data, knock on wood, because we keep a copy of it in memory on another server. So your database has a copy of the data in memory on another server as well. And then on top of that, we save that to disk. So if your first instance disappears, we automatically fail over to the second instance. And if for some reason both of them go away, we actually have the data on disk. And we can talk more about that later, but I just wanted to get that out of the way right away. Turn the volume down here because that was a little loud. All right, so we also offer it through deployments that we have made specifically on AWS, on Microsoft Azure, on Google Compute Engine, and on IBM SoftLayer. So that means we actually have gone and deployed Redis clouds specifically on each one of those. Because Redis is extremely fast, you don't want to go across the public network to get to a Redis database. You need it to have it in the data center where your application is actually running. We also have integrations specifically for platform as a service offerings like Heroku, Pivotal, IBM, Bluemix, OpenShift, AppFog, and a few others. So if you're using a platform as a service offering and you just want to get a quick click of a button, get the configuration details and add them into your application, you don't have to deploy anything, and you have a very quick and easy integration with your Heroku app or whatever it is. So we've been doing that for a long time. We're very good at that. And recently what happened was we said, no, now that we know how to package up and deploy this stuff, why don't we let others take that same software that we use and give them the ability to download that and run it in their own data center. So now we have something called Redis Labs Enterprise Cluster, which we lovingly call Arlic, which rhymes with garlic. I don't know if that means anything, but anyway, it's kind of gives you the ability to do Redis on-premise, right? So you can deploy your own Redis cluster in your own servers. Okay, so, or we can also, we don't have this on our website, but we can actually manage it for you wherever you want it to. So we have the ability to actually remotely manage it for you if you don't want to do it yourself. Okay, so that's enough about our company. The rest of the talk, I thought I'd talk mostly about Redis and probably go off a little bit, some detours a little bit. But Redis is a very cool database because it's extremely fast, okay? It's incredibly open source, so lots of folks use it for a lot of different things. It's in memory. And most importantly, what I'm here to talk to you about tonight is the fact that it is a data structure store. Have you guys ever heard of a data structure store? Probably not. Redis is fairly unique in this aspect. So this is the #1 takeaway for the evening, okay? That it is a data structure store, and I want you to walk away knowing what that means. All right, I'll get to that in a moment, but you can use it as a database, as a cache, and a lot of people actually use it as a message broker. All right, and again, I'll get to that in a minute, but the message broker concept I'm not going to actually talk about a whole bunch more, so let me just mention that because it's in memory and it's very lightweight structure, it's extremely fast for moving bits around. So if you have a whole bunch of data that's coming in that your other database can't handle, Redis is a great way to absorb all that data, put it into a queue, and then dump it into the database when the database can handle it. Because Redis is that fast. You can just kind of use it as a buffer for just about anything that comes your way. It's extremely popular. It is used by just about every one of these, quote-unquote unicorns and all the other high-flying websites. Again, why? Because it's just fast. Why spin up 30 servers of a different type of database when you can have one Redis? I mean, it's that fast. Okay. So you can think of Twitter. Twitter is essentially a bunch of code wrapped around Redis. It's basically what it is. So when you do your tweet, it's going up into Redis, and then it's figuring out what it needs to do, who needs to receive the messages, who has their web browser open right now, and it's setting up the pub sub or whatever it needs to do, and it's doing all that in memory, and then it saves it to disk. But it's got to do it quickly, so they use Redis. And just about everybody else uses Redis too. And it's now starting to move into the enterprise as well. We have a large deal that we did with Alcatel-Lucent, which is now packaging that up as a part of their offering. And you know they sell a lot to telcos. So it's the real deal. Now, let's get on to data structures. It's pretty cool. When you look inside of Redis, you start realizing that there's a lot of amazing stuff going on in there. And you might remember this from 2001: A Space Odyssey. Oh my God, it's full of stars. Well, Redis is full of data structures. And here they are. These are the data structures. Now, a lot of databases, like let's just go back a ways. Let's go back to, I don't know, like SQL Server, or MySQL, or one of those SQL databases. They basically have one structure, and it's a table. And you put your data in it, and then you can do things like indexes and joins and all that kind of stuff. But you've got basically a row and a table, right? That's your structure. You don't have a lot of variety there. And there's a lot of overhead with that table. You know, all that indexing and all that extra stuff that goes into it slows things down. And that's really what NoSQL was meant to do, is to release the database from a lot of that extra structure so that it can perform a lot quicker. But even the NoSQL databases that are popular, MongoDB, for example, which, by the way, I love Mongo. I think it's great. It's easy to get going. But it gives you one structure. All right? You've got it basically let you put your JSON in there. They call it Bison. Yeah, Bison, Bison. You say Bison, I say Bison, whatever. It's one of those. Binary JSON, right? So, but they basically give you that one structure. Well, Redis is trying to be as fast as possible. And just like a car, when you drive a car around and you want to have the fastest possible car, you might get a Formula One, right? That's not going to do you a whole lot of good if you're going off-roading. You need a different type of car, right? Or if you're on a boat, okay, a different type of vehicle. So Redis has different structures based on the type of functionality that you need. So a very simple one. By the way, it started off influenced by Memcached. Okay, how many of you are familiar with Memcached? Most everybody. Okay, sure. So Memcached is extremely, it was created for LiveJournal, a blogging platform where it's mostly reads. So put that in memory and you get the responses pretty quick. It was sort of inspired originally by that, but Memcached is very simple. It's basically just key value. Right? You don't get a lot more with that. That's what the string is here, by the way. It's basically key string. Okay. But Salvatore is working on a project, and he needed to have some sort of list, and he needed it to be extremely fast, and he could not find a database that could perform fast enough for his project. So after trying other databases, he eventually decided to create it himself, and that's how Redis came into being. He needed something faster than was on the market at the time, and he started off with lists. Now what a list is, it's a very simple structure. It's kind of like key value, where you have a key and a value, but it has one extra column or one extra value, which is a pointer to the next key. That way, when all of the data is coming in and you want to process that data in order which it came in, you can then grab a key, process that value, and then you know where to go for the next key, right? Because you got the pointer to the next key. That's what a list is. Very simple, extremely simple. And it's in memory, and it's highly performant, and that's why it's the fastest thing on the planet. Now, he found other use cases that he needed to solve, and he didn't want to throw everything into one structure and start slowing down the list structure, so he created another structure. For example, for sets. Sets are simply key value where the values are always unique. So you can't add a duplicate value in. In fact, if you're trying to track unique visitors to your website by IP address, all you need to do is just tell the list, here's the IP address, and you don't even have to do anything else. Because what sets will do is sets will accept that value if it's unique, if it doesn't already exist. If it already exists, it just ignores your request. All right, that's the fastest way to handle that problem. And so it's done that way on purpose. So sets are just all unique. think about things like your social network, your friends. Okay, you don't have the same friend duplicate, right? You don't need that. So there's a lot of examples where you just don't need duplicates. Sorted sets are even a little bit more structured. Let's say you want that unique set of data, but you want it ordered by some score or some value. So there's another column that they've added there that gives you that ability to automatically sort the data. So for example, let's say you're playing a game, like a massively multiplayer online role-playing game or something like that, and you want to know, and everyone's score is constantly changing, okay? You need to quickly be able to update that key value score, and you need that score, that leaderboard, to automatically resort immediately. And that's what Redis does. So as soon as you add that value in there, or if you update a value, it automatically resorts the table, or the sorted set. And therefore, all of the viewers who are reading that sorted set don't have to do a query to get the update, or to get the latest version. And I'll come back to that because it's a pretty good example. Now, these, well, let me go back to the first two here. So strings, we already talked about briefly. Key, value, it's literally like the simplest possible database you can have. There's not much to it other than you can put different types of, you can use it for different types of things, but essentially it's a string. And then hashes. Hashes are kind of how you deal with, if you want rows, essentially. So if you're trying to store multiple values with a key, you usually would do that with a hash. And all you're basically doing is you have your key and your value, but then you've got, with that, you've got fields that you can specify. So field, value, field, value, field, value. But that's all stored essentially in a big long string. And Redis lets you have specific operations that let you get the data, put the data in and pull the data out in those fields. But it's essentially a big long string. Okay. So I'm oversimplifying things here, but I just want to make sure that you understand fundamentally what's going on here, which is if you're trying to be the fastest on the planet, this is how you do it, right? Specific structures for specific functions that you're trying to perform. Now, I guess Salvatore was bored or something, because these 5 structures right here are really fundamental building blocks. But there were things that were requested of Redis to perform that you could do with these structures, but it took a while. Like even in memory and even with the simple structures that were extremely fast, there were a lot of effort to go in and performing some functions. So for example, bit arrays, or bit arrays. So a bit array is literally an array of lots of bits. Okay, pretty simple. Bits, as you know, on or off. That's all you get, right? Now what might you use that for? Let's say you're Pinterest, and you want to take all of your 100+ million users, and you want to know which one of them are online right now. Okay, it's a yes or no question, right? So they take all 100+ million, put each one of them in an addressable bit, and turn it on or off. So you basically got a big giant array. And they put all of their users in there. And if they need to know, like when you first log on and that page appears and you want to see like all of your friends, and has a little green or red dot next to it, you can then see are they online or not. But more importantly, if you make an update and now you got to message all the folks who are your friends or followers or etc., you want to be able to send that message to the ones who are online right now, and you don't bother sending it right away to the ones who aren't online, right? So you need to very quickly be able to access a server that can tell you which ones are online right now and go send a message out. So that can be done with a bit array. So a bit array is kind of built on strings. In fact, all of these are kind of built on some other structures. Hyperlog is another kind of, I wouldn't call it whimsical, but sort of exotic structure, where let's say you're doing a Google search. And you know how when pick some word, doesn't matter, pick Redis, and they'll tell you, oh yeah, the word Redis appears on the internet, I don't know, 15 million times or something like that, right? You all seen that? Anybody know what the actual number is? I don't know. I should probably look it up. But it tells you that number. Now, you can type pretty much any word you want, and it's going to tell you how often that word appears on the internet. Do you think it's actually going and looking up some sort of index right then and there? No. That would be a lot of effort for not a lot of value. What they're doing is something similar to a hyperlog log, where you take a whole bunch of data and you feed it through this process, and it basically creates a statistical estimate of how often that word shows up, right? And then it basically flips a bunch of bits, and you take like a terabyte of data, throw it through this thing, and it can actually figure out how often each word shows up, and keep all of that in about 12K. And this gives you the ability to then put that 12K on multiple servers, and then that's how they get that super fast response, because they're just basically looking up an estimate. And it doesn't really have to be accurate. I mean, do you really care if it's like 15 million or 14 million? Probably not, right? It's close enough. And it turns out that this hyperlog can actually be roughly around 98 or even 99% accurate. So that's going to be pretty good. So there's a lot of these types of things where you just want something to be super fast, and it doesn't have to be perfectly accurate. In fact, perfectly accurate would take way too long and not give you the value. So the last one I'm going to talk about here is geospatial indexes. This is a new one. Yes?
Does a log use a Bloom filter to determine whether it exists?
Well, it's similar to a Bloom filter. Bloom filter is basically, is this word in that list or not?
They give you absolute, it's not in there, but not positive it is.
Right, so kind of like a Bloom filter, but it's not the same. But it's kind of in that world, right? And so, okay, so the last one is geospatial. So, it's like everyone's favorite thing right now to be creating a startup that's like the Uber of this, the Uber of that, right? I even ran into, I was here in New York for Container Days a few weeks ago, and I ran into some company, and they were like the Uber of personal storage. Anybody know this company? I forget what they're called.
No, but it's a big black market in New York, by the way, for the fraudulent, like, Gucci and Prada handbags.
There you go. So that's why I started here. I said, and how might you know this?
How would I know that? Because my one investor has a DoD UID-based one and one for the luxury goods market.
Okay.
For verification. It's benefit or not.
That's interesting. So yeah, I'm just trying to figure this out. Like, I'm thinking, is somebody? Well, when I first heard about the Uber of personal storage, I'm like, is somebody driving around with a truck of storage or something? Like, come to you? That seems awfully odd. But I think it's more like if you have an extra, closet or something. I don't know. But anyway, odd. There's something for everything, I guess. But geospatial, the way it works is kind of interesting. It actually uses a sorted set. So you have essentially a big giant index, okay? And what's going on is, if you know how lat and longs work, longitude and latitude work, you basically have a number. And the longer the number, the more you can zoom in to a particular location, okay? For example, if you just took the first two numbers, the first number of the lat and the first number of the long, you basically have narrowed down the Earth to about 10% of the Earth, okay? I'm sure you can do better than that, right? But if you add more numbers, you get closer and closer and closer to a city or a block or a building. So what they've done with Redis is they've taken the first number of the lat and the first number of the long, and they alternated them. And then they take the second number of the lat and the second number of the long and alternate them. And they just keep adding until they get all the way to the end. And this makes it easy to search because you can then determine how wide of a range you want to search on. And if you just pick the more digits you search on, the narrower your focus area. Now, the narrower you go, the longer the results take, right? But if you don't have that many numbers, or if you don't have, you don't need to be too specific, you can get back your answer extremely fast. Now, it may not be the absolute perfect way to do it, but it's definitely the fastest way to do it. So that's how Redis is providing geospatial. Yes?
Does that integrate with like the U.S. Census Tiger files or OpenStreetMap?
I would imagine it does, but I haven't done that yet because I think the Tiger files do come with a lat long, but I don't.
More accurate.
Yeah, but I don't know. So you would basically take those numbers, throw them into Redis, and it would do which basically interweave that data, and then you use it to search.
Very exciting.
Yeah, it should work. Well, it's brand new. Well, it's brand new with Redis 3.0, or 3. Something, but fairly recent. So there's actually a lot of excitement around it because it is a very inexpensive, fast way to do the Uber of whatever. Okay. Okay. So now the takeaway. I'm kind of jumping to the punchline here, but the takeaway is that Redis gives you all these data structures, but it also gives you a whole bunch of functions. There are over 180 functions that you can use with these data structures. And the reason why you need all these functions is because you're not using SQL. You're not passing in like a select statement with a where clause. You're not doing an insert statement. You're not passing in this well-known language to perform the work on the server because it's not a structured query language. So instead of creating your own instructions through a query language, you actually specify a function, and that function does the work that you were trying to perform. So you have to learn a lot of functions, but there's a lot of them that are really popular. In fact, the Redis.io website is very, very good at providing you the instructions and the information you need to find the right function. So in fact, you can, on the Redis.io website, in fact, let me show you this. Okay, you guys can see that, right? So at the top, you go to commands. And here you can choose filter by group. These are mostly structures, but not all. There's a few other groupings as well. But for example, you can take hashes, and you can see these are all the functions that you can use with hashes. And let's see, like for example, this one, I'll come and talk about this one later, this h increment by. A hash, as I said before, is kind of how you would store like rows, data that goes with the key, like you would normally put in a table. And if you want to just update one field, you don't want to query that row, or that hash, pull all of the data into your web application, into your code, pull just out that one field, update it, and send it back. You don't want to do that. That took 2 round trips, and you had to read a bunch of data. Instead, Redis is trying to be as fast as it can physically be. So instead, what it's going to do is it's going to say, tell me the name of the field you want to increment, tell me the amount you want to increment it by. It's going to send the request to the server. The server is going to go, and it knows where each one of those fields begins and ends, and it's just going to manipulate the bits in memory that increment that value. That's far faster than you doing it yourself, right? So that's what's going on here, is there's a bunch of these functions that are written in C in the best possible programming techniques that the world can find, and it's all been crowdsourced through companies like Twitter and Instagram. All these companies have been using it and contributing their input to make it better. So, like, who can compete with that, right? That is the best that our global collective minds can come up with. So you get a lot of power out of this, and it's free. It's crazy. All right. Also, while I'm here, let me show you. You pick a programming language. There is a client for it. Okay. What's that? There's Go. Oh, and guess what? There's a lot of them. So it's not like there's one client. There's, how many Go clients are there? Okay, yeah, like 10 of them. So it's extremely popular. What? There's one called Ready Go. So there's one in Tickle and Visual Basic. Who would want to do Visual Basic? MATLAB. I mean, there's a whole Lua. There's a bunch of Smalltalk. This is programming in Smalltalk. All right. So the Elixir. I mean, you got pretty much everything out there. Dart, Rust. Okay. So pick if you're going to use a really cool database like Redis, choose a cool programming language and program with it. That's something new. Okay. And let's see. Go back to commands real quick. One other thing I just want to show you is that with these different functions, there will be a like big O, they call it big O notation, which is basically a way of determining how long a function will take to complete based on the type of structure you're working with and the amount of data you're working with. And you can actually predetermine ahead of time how long it will take by using the formula. And it gets into logs and all these things too, so it's, I don't know, it's kind of cool to learn about. Okay, so it's definitely a lot of value in just simply learning about Redis because it's well written and it's also completely documented. So again, you take these different structures and you put them together like building blocks, combined with the functions that you need to perform the job, and you are going to be able to perform the fastest that man physics can perform. Yes?
Can the structures be nested?
Yeah, I mean, I think I know what you mean. For example, let's say you actually wanted to do something sort of like a table with an index, right? You could combine. It's not really nesting. You're just kind of using them together. So what you take is you take a hash when you put your fields in there, and the field that you want to be indexed, you then take those keys and you put them into, for example, a sorted set. And so now you have that sorted. You go search through the sorted set for the value you're looking for, and then go find the key in the hash, and then look up the fields there. So you're kind of putting them together to essentially perform what would be a normal index in a table, right? But you can combine these things however makes sense. Okay. So let's see. Before we go any further, I get a lot of questions about things like transactions. I mean, there's a lot of different questions that come to mind when you're dealing with memory. Because if you're doing things in memory, that brings up questions around like, well, wait a minute, what if the system crashes? Where did your data go, right? Also, Redis is single-threaded, so it's basically one thread at a time, or one thread is operating at any one point in time. There's not multiple threads trying to talk to the data structures. Now, this is good and bad. I mean, it's good in that you don't have to worry about race conditions or thrashing where you're updating you're in the middle of updating a bit of data, but before you complete, another request is trying to update or has updated that data. Like that can't happen, right? Because it's one thread doing one process one at a time, one operation one at a time. So it knows that it's the only thing operating on that data. Nothing else can kind of come in on the side and compete with it. Now, that's not completely true because you could have multiple web servers that are all talking to the database, right? Well, in that case, if you really want to make sure that no other request came in between your two requests, you can do something like a multi-exec, and you can string multiple operations together and make sure that they're all happening before another request from another server comes in. And yeah, you can basically batch the requests together. Okay, so now, because it's single-threaded, if you have a server that has multiple processors, well, you can't take advantage of those, right? Because only one processor is going to be working with Redis. So there's two ways to deal with that. Number one, if you really want the extra power, you can shard your database. So you basically have multiple Redis databases running on that server, and each one of them gets the full power of the processor. Okay, and so you're basically splitting your database into like 4, for example.
Just to be clear on that.
Yeah.
When you say database, you don't mean the physical Redis process, you mean database inside of Redis.
Well, okay, let me make sure I understand that. So Redis, when you install Redis, you have one database.
Yeah.
Yeah.
And one process.
Well, we have one database, and it can only take advantage of one process.
There's one database, which is still inside the same exact process, same course of all. It's just different management, memory management is different than the other.
Yeah, I think you're saying that correctly. What was that in the last part?
It's you have one physical process running, but there's two databases inside of one process that are isolated between each other. So there's one thread on this, one thread on that. There's no comparison. They're different.
Right. In that case, it'd be completely different. Right. Absolutely right. Right. But where I think where folks struggle is if you want that database to have the power of say 2 processors, you can't take advantage of it. Right. So in order to take advantage of two processors, you would essentially shard your database and have two separate shards all making up one database. You can do that. So the other thing is with just a little
How do you do the sharding?
yeah. So you can do it yourself. So there's instructions on the open source website on how to do that. And of course, we do that out of the box with our product. So if you want it easy, you can pay for the enterprise product that we offer. You can still do it, but it's more work, and you can do it with the open source version. Yeah, there's a lot of tricks to making it faster and more organized and all that kind of stuff. Performant, and we try to put all the best practices in it. And that's how we make money, is by operating multiple databases for folks.
Sure. Do you scale the shards? Do you need 8 servers, maybe 16?
Yeah, we do that pretty much out of the box. Our cloud has been doing that for customers for 3 years. We had a customer that basically started out essentially on our free version, and now they're using 8 terabytes. So that's like 60 servers, all in one database. Lots of shards. So that's how we make our money, is doing that well. Yeah. And backwards.
So when you mentioned single-threaded, if you have a cluster of servers, that's still one thread in the cluster?
Well, if you have a cluster of servers, then each shard can take advantage of its own processor, therefore you're getting more power.
Okay. Do you have one shard across multiple servers?
No, each one of those servers would have at least one shard. Okay. Yeah. Yeah, so this is okay, I'll tell you what, I'm going to answer this question and I'm going to go on and we'll come back, okay, because this could really go off in a lot of directions. What we do, and what we recommend you do, is if you go beyond one physical server, you have your database sharded across multiple servers, you actually proxy through one primary server, and then what we do is we pipeline, we basically have a pipelining process that takes a whole bunch of the requests, queues them up, and sends them across to that server, the other server, all at one time, operates those operations, returns, and then that way you don't have all that back and forth, which basically wastes a lot of time.
How do you handle multiple client connections simultaneously?
Yeah.
You mean
so,
they're not the request itself?
So let me come back to that because I'm kind of off in the weeds right now. I can tell some folks are kind of like, well, I don't really care about that. So let me keep moving. And we'll come back to that, okay? Okay. So now what I'm going to do is I'm going to give you a couple examples. How does Twitter, how does Instagram, how do these companies actually use Redis? And oops, what is that? Oh, I got to do a backup, I guess. No, it's my Backblaze. I switched laptops and everything like that. Okay, so let's talk about extremely popular use cases for Redis. The first one is going to be if your web application is getting hit a lot, the first thing you're going to do is you're going to take that and split it across multiple servers. So you're going to take and start scaling horizontally. That's basically rule number one in the cloud. When you start running into scalability problems, it's probably not the database right away. It's probably your actual web server is not able to handle all the requests. So what you can do is you can take your application code, put it on 2 servers, put a load balancer in front of it, and now you have 2, 3, 4, 5, whatever servers handling the requests. The problem with that is that a lot of programming languages can handle sessions in the framework itself. But as soon as you go to multiple servers, now that user login information, when somebody logged in, the cookie information is only stored on that one server. Well, the load balancer is going to send them to another server next time, and now they're not logged in. So you got to have some way of sharing the session information across all of those web servers. Now, an easy way to do that, and the most recommended way to do that, is to put your session data in the database. Okay. Now, it turns out Redis is perfect for this, because you don't really need to persist session data to the hard disk. You don't really care about that. If everything were to go to hell and were to crash, your servers are down anyway, everyone's going to have to log back in anyway. All right? So you don't really care about that. So storing it in memory makes tons of sense. So Redis, you stand up a database on a separate server that all these 8 web servers can share, and they all talk to the same Redis instance to share session information. Okay? That way, Once you've logged in on one server, it updates the database, the Redis database, stores the session information, and then no matter what server the load balancer sends a request to, they all talk to the same Redis instance and can confirm, yes, this person's logged in, and respond with session variables that are used to create the web page. So very, very common use case for Redis. In this particular case, they're using a hash. Why? Because you want to store lots of data with your session variables. So you put them into fields and store them in a hash. Another nice thing about hashes with Redis is that you can set a time to live so that every session automatically expires after, say, 20 minutes. Okay? And if the person doesn't visit the web page for 20 minutes, they come back, they're forced to log in again because all of the session information has expired. So again, that's a very common use case. It's a very simple function. hset lets you set a field in a hash, and hget lets you get that field. Very simple. And I talked a little bit about increment_by, which lets you increment maybe a hit counter in that hash, so that you can just say increment by 1 every time they come to the page. Okay, so that's a user session. Here's an example of how it would work. By the way, the client library that you download and install, very simple. Okay, you set it up, and then you're basically going to say, client.hmset, superset, right? So this would be the function you call. This is hm with the m, basically is multiple fields. Okay, so you can actually set multiple fields at one time. All right, with hmset, so it's hash multiple field set. User session 1, they have their particular user ID is 8754, their name is Dave, and that's the IP address. You throw all that in the hash, and now that's stored for all of your web application servers to use. You want to get the data out, you can use hmget, you can pass it in each one of the fields you want, and it'll return them. Or hget, and you can just get one field. H_by, we already talked about, and here you go, hset, hget, hdelete, okay, if you want to update or get or delete a field. And then if you just want to kill the whole session hash altogether, you just use delete, which is just delete the key, basically. Okay. So this is how you would do sessions. Anybody have any questions about that? It's pretty straightforward, right? Pretty easy to learn.
Where does it run? Is it run in some kind of shell or Java-like or whatever, language library? Or where is
it's
it
all written in C. So it's a C
So
program.
these commands you're asking about, these commands, there's actually a program we use called Redis Desktop Manager.
So this is just a C library, basically.
Well, these are the commands you would send to the server. So
Yeah,
it can
well-
be sent from.
Yeah, so the question could be like you're on your web server in PHP or something, and you have a PHP library that knows how to talk to Redis, and Redis is running on another server, right? So you can actually run it on the same server too, but for this use case, you probably wouldn't be running it on the same server. But Redis is a C program running on another server, and then you have a client library that knows how to talk. And what's missing here is the client library. You pass it every single time. You're passing in the URL, the port number, and the password every single time. You're passing that in to the client. Okay.
And how does it go? Is it HTTP or how does it go?
I know the answer to this. So it's its own proprietary protocol, TCP, and I can't remember. And it's over a specific. Yeah, every time you got to specify the port. Yeah. Okay. So that's how you do hashes and sessions. The next one I want to share with you is a message queue. Okay, also very, very popular. I wouldn't say that everyone knows about this, but once you learn about this, you realize how fast and efficient it is. It becomes something that you start using. In fact, Netflix uses Redis like crazy. And every time I run into them, I always like ask them like, "What are you using Redis for?" And they're like, "Well, what are we not using it for?" I mean, they're using it for a lot of stuff. I asked some guys, because I just created a Redis meetup group in Silicon Valley, and I said, would you guys like to come and speak in my group? They're like, sure, yeah, we'd love to come and speak. Well, what would you like to speak about? They're like, how about all the different ways you shouldn't use Redis, but we do? So they just use it a lot. Because in memory, you can do a lot of things with it really fast, and maybe you shouldn't, but it's easy. Yeah.
And regarding message queues, because I use them a lot, was the inventor of Redis also the inventor of DiskQ, which is
Yes.
based on Redis? Okay,
Yes.
because I've used it and it does not work well.
It's early.
I know.
It's not really done.
Right.
No.
Okay. So
Yeah, it's kind of his pet project right now.
Which is it?
I see.
It's
So
called
it is
DiskQ.
project. Okay, cool.
Yeah. Yeah, so it's not done, and he'll tell you that. But people are using it, but
Yeah.
it needs still
Right.
some work. And remember, he's going for speed. Okay, so
I know.
there's probably some things that he's doing right now that are not working all that well because he's going for speed, and then once he gets the speed
I
he
like
wants, he'll make
speed.
it work, right?
Yeah.
That's my guess.
Okay.
Yes.
Since you mentioned the Netflix thing, what would you say is like one thing you should not use Redis? They see people using it.
Okay, I actually know the answer to this because I've asked this question of people who really do know. Joins. So you want to do like typical database joins. Not the best in the world. There's certain things you can do with Redis that are like joins, like intersections of similar data structures, but like taking two separate structures that are completely different and trying to do like a select statement or whatever across multiple, it's just not good for that. So if you need to do that kind of thing, then find a different database. It's just not the best for that. So SQL, I don't even think there's a library. Actually, I take it back. I think there are libraries that will give you an SQL-like interface over Redis. It's just kind of a bastardization of what Redis is supposed to be. Okay, well, let me keep going then. All right, so managing queues. Queues, like I said before, using lists. Okay, the functions are super simple. Left push or right push? Do I want to push to the left side of the queue or do I want to push to the right side of the queue? And you get to choose what's the front and the back. Okay, for whatever reason, when they talk about lists, they think of it as like a top-down thing. Okay? I'm sorry, they don't think of it like a top-down thing like I normally think of it. They actually think of it as like a horizontal list. Okay, so that's why it's like left or right push.
They should put that in the documentation because I thought so.
Well, it's just, the L
Maybe
is
they do, but
left
I didn't know that.
and the R is right.
Right.
Yeah.
That makes sense.
So, yeah, and it's kind of cool. Like, this is basically you have a bunch of things that need to get done, and maybe the processes take a while to run that. So, you got a whole bunch of devices or something sending data to your server. Put it in Redis, and then let the processes run and grab the data out of Redis to complete the work that needs to get done that can't be done in real time. And Redis is great for that. Like I said before, like Twitter is basically a bunch of code written around Redis, like really. And so when you tweet, it's got all this stuff to do, and it's all being done by getting data in and out of Redis.
It's a queuing system, but it's based. The key is speed. I'm assuming there's other queuing systems where you're going to get acknowledgements and tolerance and stuff like that. I'm assuming that is good.
Right. It is not meant to be a completely feature functional, queuing mechanism. But you will find that there are a heck of a lot of libraries out there that that have all that functionality, and then they'll use Redis as the store. Okay, there's tons of them. Is that
Sidekick, which is Ruby-based.
Sidekick? Yeah.
That's why it's basically
Yeah, I'm blanking. There's actually some popular ones that I'm blanking on right now. Okay, so what I want to show you though is again, there's all these functions, and it's your job is to find the function for the job that works with the structure you're using. And in this particular case, let's say you've got some data coming in, and it's not just one process that needs to be performed. There's two processes. So when the first process is done, you want to remove that item from one queue and you want to push it into another queue. So the second process knows to perform, right? So let's just say you're getting started with the first queue. You can use L push to push orange to the left, then green, then blue. So as you add more, of course, the values get pushed in. And then I can say, you know what? Red is really important. I need to do that right away. So I'm going to do an R push. I'm going to push it to the front of the queue. I'm going to call that the front. Okay? And now I've got this queue. And I'm going to perform some work. And what I want to do is, when that work is done, I want to put it in another queue. Okay? Now, it's kind of how it gets kind of funny here. The function to do this, to move it from here to there, is rpop_l_push. These functions get really funny names after a while, but there's a little bit of a method to the madness, so you start recognizing what they're doing. And this is popping it from the right of this queue and pushing it to the left of this queue. And that's literally what it is. It's Q1, Q2. And because you said R and L, it knows from the right side and the left side. It's very, very simple.
So basically, it's a batch request on one command for each, and then I'm going to batch request.
That's right, because it's all happening in one operation on the server, both of those queues, right? So you don't have to worry about like pulling the data out of one queue and then your code crashes before you put the data into the other queue. Now you've lost that data, right?
Before they use it, when you create a batch, they do the commands on the run, go execute them, will be the same thing, popping here.
Right. So once, I don't want to speak for Salvatore, but you can imagine there's so many people out there using Redis that when a function becomes, when some sort of operation becomes really popular, the request comes in, can you please just make a function for this? That's kind of how these 180 functions rose, right? Okay. So let's go to, I've got 2 more here, and then we'll start wrapping things up. So managing tags. Tags are obviously very popular. Tags can be used for a lot of different things. You can use them as categories, but you can, I think tags are more often used as just kind of like random bits of data to describe something. Kind of like taxonomies or whatever you want to call these little bits. And so the problem is you got lots and lots of tags, and you want to, let's say you're working with some blog posts or some articles or some products, and they've been tagged with certain things, and you want to find, let's say, all of the blog posts that have these 2 tags, right? So this works great for like recommendations as well. You can imagine like somebody's tagged an item and you've just viewed it. Well, what are all the other items that have those same tags, right? So it's very popular for recommendations as well. So here, in this case, we're going to use sets because you don't need duplicates if you got tags. There's no sense in having duplicates. You just want to count how many of them of a tag there is. You don't want to have like duplicates of the tags. So you're going to use here, you're going to use set add to say, this article 1 has tag 1, tag 22, tag 24, and tag 28. So you're going to add basically a set called article 1 that has these values. Okay? Now at the same time, because this is NoSQL and you don't do queries with joins, you also have to go add all of the articles to the tag. Okay? So you have to basically duplicate your data. This is just how NoSQL works. Okay? So you also are going to add the article to that tag. All right, we all good here? All right, that's just how SQL works. NoSQL works. If you were doing NoSQL, if you were using SQL, you'd normalize your data and you wouldn't have duplicates as much. Okay, but with NoSQL, this is just how you have to do it. Now, what you want is you want to know, which articles have these 2 tags, or the similar tags. Let's see. Yeah, tag 1 and 2. So what we're going to do here is we're going to add all our tags, and then here you can take them. You can see does this article have a tag? Here you want to see all of the tags for that article, and here you can use s-intersect basically and say, give me the articles that have both tag 1 and tag 2, and here you can see that it would be article 3. Okay, so this is how you would do this extremely fast. Now, let me give you some examples where this actually is very, very popular. Okay, obviously recommendations, but you ever go to, Facebook? So if you go to Facebook, but hey, do you remember going to a user profile that like, maybe, I don't know why you went there, but like all of a sudden you look at somebody's profile and you're like, I have no idea how I got here, but I'm looking at this person's profile page, and it's now telling you, here are the friends you have in common. Have you ever noticed that? Like I was kind of scratching my head, how are they doing that? Like, because to pre-process that would be a little bit insane. Because what are there, like 1 billion people on Facebook right now? That'd be like 1 billion to the billion. I mean, that'd be like ridiculous pre-processing, right? So no, they're actually doing that matching in real time every single time you go to a profile page. They're actually taking your set of friends and they're doing something like this, an s-inter, with their set of friends and calculating that right away. That's I guess a better way of doing it, but still, that's pretty awesome power. Okay, so you can do that yourself with Redis. Final use case, again, leaderboards. Now, there's lots and lots of these use cases for sorted sets, etc. But this is an easy one to visualize. Let's say you've got many, like thousands of users all playing a game, and obviously as they're playing the game, their score is updating constantly. And like I think I've given you this example before, but in real time, you're trying to display in real time the information. So there's a conflict there, right? Because you need to update that leaderboard list, or sorted set actually, if I use the right terminology. But you also have a whole bunch of viewers requesting the current list. Now, the easy way to solve this problem is to cache like the top 10. Okay, top 10. That's not a hard problem to solve. You're just caching it, and there's reasonable ways to do that that are pretty simple. But how many of your users are in the top 10? Right? They're not, right? Like if you got 1,000 players, most of them are not in the top 10. So they don't want to see who the top 10 is. They want to see the person who's right ahead of them or right behind them. That's who they want to see, because that's who they're actually competing against.
If you just entered the top 10, you want to see your name there too.
Well, that too, yes, exactly. You want to see it right away. So Redis allows you to, whether it's a top 10 or any 10, or any number, to be able to see that range immediately. So you're going to use the sorted set as Z. Z stands for sorted set, I guess, to add, and then you can find the range, and then you can actually get ranks and all that kind of stuff. And that's all done basically, for game 1, I'm adding a bunch of users, and this is their score basically. Okay, so you can see that I've added 4 game players here, and I've added their scores: 1,000, 2,100, 3,400, 3,500. And let's say some player 3 actually, something's not quite showing up there, right? Okay, let me just do that. So player 3 gets 10,000 points, bumps them up here, okay? Now I can do that in one of 2 ways. I can actually specifically go and update the value and set it to 4,400, or I can use Z increment by and tell it to add 10,000, and then it basically goes and finds that little place in memory and changes the bits to make it to add it 10,000. Okay, and then I can go and get the. In this case, what you're going to want to do if you want to see the the top-down players, you would do Z reverse range, and you start off with player 0, which is player 1. You can just tell it I only want the first 2, and that's going to give you the first 2. And then if you add with scores, you're going to get the score value back as well. Okay, so that's how you can use sorted sets to do leaderboards. Now, I'm going to start winding down here, and I can start taking some more questions in a moment. But I just want to kind of make sure I summarize the point of this talk. When you're supposed to say what you're going to talk about, and then you talk about, and then you tell everyone what you talked about. Okay, so this is the third part. So we've got all these different data structures, and you find the right data structure for the job. It's extremely fast. You've got a bunch of these functions that you can use with those data structures in there, and find the right function, because it'll be faster than anything you can write. Okay, and because you just have 2 things to choose from, a data structure and a function, it's really simple, and it's extremely popular, partially because of that. Now, our company provides you the persistence, the scale, high availability, all that other stuff. You can do it with open source. We just make it easier, and that's what we find is that sometimes you'll have some really talented engineer who will go and implement open source Redis across the company. Everything's going great until they leave. And the company's like, oh. They'll call us up and say, can you just help us with this? And then they pay a little bit of money, and now they got a supported product. So I mean that's kind of what happens a lot of the time, or things just get unwieldy, and that happens too. But enough things about us. That's basically it. Now, if you want to learn more, I'll take questions in a minute. But if you want to learn more, the open source website it's very popular, very easy to read. It's a good resource to find things and learn from. Again, there's this ebook that we have up on our website by Dr. Josiah Carlson. This guy is totally geeked out, and he'll go into a lot of detail I was listening to one of his podcasts, and I like listen to it while I'm jogging, and I'm like having to constantly rewind because this guy is like cramming a whole bunch of stuff in like one sentence. It's pretty impressive. You can also get a free 30 megabytes of Redis if you go to our website. This is production grade. Yes, we support them at different tiers, but it's all managed the same way. So you're going to get a very, very reliable. It's not just a funny Redis instance. It's a very reliable Redis instance, up to 30 megabytes for free. After that, you start paying based on usage. We just entered into sponsoring a hackathon. If you want, you can go to coding.com and click on our hackathon button. There's a hackathon there. I think there's like $150,000 in prizes. So that could be fun for you. And then if you want our software product, we don't give it away right now. We're not giving away free instances or free software, but you can download and trial and try it out. And if you have a really good use case, we can send you a key and you can try it for a while and see if it works for you. So, but this is the resources I have for you. So before we do our drawing, let me leave these resources here. Okay. I want to take some questions.
Wait. Before we do questions, I just want to give first a great big round of applause to Dave Nielsen. Second, please everybody put their business cards into this container. I can just take it and pass it around. Because
he's like, yeah, I did. Take it back.
Yeah. He wants to maximize his chance.
That's right.
But someone is going to win that Star Wars BB. Vish, can you hold it up?
Yeah, sure.
Star Wars BB-8. If anyone wants to Google it, you'd be surprised. They are really expensive. At least for a kid's toy. Or geek toy. I shouldn't say kids toy. So, okay, we're going to give that away very shortly.
I resemble both.
Does anybody not have a business card to put in there? All right, so everyone with their hands up, Vish will give you.
Yeah, and I think most people probably meant Vish.
Okay, let's take some questions in the meantime. Oh, and great questions, get great shirts. So, like, the very first question is,
Do you have a
that's the question, there we go. You guys can just change
Sword sets? Okay, so the only answer I have for you is some of the structures have time to live and some don't. Right. I can't remember if sword sets it does not. So by default, no. So you have to keep track of that yourself. Now, one thing that I have noticed is that I didn't talk too much about Lua. How many of you are familiar with Lua? All right. What's that? It's on the website. It's on the website. So go look at the website. I'm done. No, I'm kidding. So Lua is a programming language. It's an open source programming language. It compiles into C, so it's very fast, and it's integrated. It's integrated into Redis. It's not part of Redis, but it's integrated into Redis. And so if you want to write some logic that happens in Redis upon certain triggers, then you can use Lua to do that. So what you could do, I'm just kind of guessing, you could maybe set a hash with the time to live, and then upon having that trigger, then go kill the set. That's maybe one way to do it.
Yeah, that's what I think. That's what I thought.
Okay.
Next question. Yes. Okay, you.
So if you wanted to use Redis as like a caching solution, right, is there like a maximum size that Redis supports as far as memory?
Yeah, you know what? That's a great question. I'm so glad you asked that, and I'm so glad you ducked. So I didn't really talk about this much, but one of the easiest ways to get started with Redis is as a cache. You should think about it as a database cache, not just static data cache. But there are plugins for just about every open source CMS out there. WordPress, Drupal, all of them have plugins to use Redis as a cache. Okay, so like literally like check a box, point to where the server is, and it'll start caching your data. So it'll speed up your website. Now the question was, how much data can you put in there? So memcached is now supported by Redis. So essentially all the functionality that you would get, almost all of the, like 99% of the functionality you get with Memcached is now supported by Redis. So it's Redis is Memcached like compliant. And Redis stores much larger amounts of data. Now I'll have to look it up, and I can look it up quickly for you in a, maybe in a minute. But it's like it might be like 256 gigs. I mean, it's a ton of memory. You can go really big with Redis, whereas with does gigs sound right? That sounds awfully big. Anyway, it's large amounts. Whereas with Memcache, up until recently, you basically had like 1 megabyte, and these like small amounts, right? So maybe it's more like 256 megabytes. I'll have to look it up. But anyway, you get a lot more with Redis. Lots of hands. Okay. Well, quick follow-up. What's the question?
Follow-up actually. So if you didn't have a cache, right? Say you had a miss, right? Is there any way to programmatically from Redis go to like another data store, like a database, and then pull that back into the cache?
The only way I would know to do that is again with Lua. So you could set something that like triggers Lua to go and do that for you. I don't know a better way to do that. What's that?
That's what Redis does. That's what we're in conjunction with Redis, threading one thread that jump into a lot of one that blocks all the requests.
Yes, so that's what happens. Now, there are ways to then call some other process outside and have it do the work. Yeah, so you can do that. As well.
So Redis obviously is open source, it's free, but the hardware on top of which it runs is not free. Obviously,
I think there's some free Sun microservice servers out there.
Memory is more expensive than hard disks. Can you talk a little bit about those trade-offs of memory versus hard disk, and what are the bills of Netflix when it comes to Redis?
Okay. So this is a question that is basically different for everybody. So I can just give you some generalizations. All right. So the reality is that there is a lot of data that you do want to store on disk for a variety of reasons. Okay. I think we don't have to argue that. But some really obvious examples would be you've got data that's historical. Nobody's really using it anymore, like maybe old scores from games that were played a long time ago. Like just keeping that around in memory just doesn't make sense, right? So you would persist that somewhere, and Redis doesn't have a good story for that. So you'd probably put it into another database like the Mongo or SQL or something like that. I actually tell folks that I think that a great combination is to use choose your favorite SQL database, choose Mongo, and then choose Redis, and then you've got basically all three of your bases covered. All right, well. Okay, I don't know what the fourth base would be, but anyway, you got your bases covered. But that's only half of, I think, your question.
The cost. Could you tell us like the cost associated of running Redis at a Netflix scale?
Yeah. So you are essentially paying for. Okay. So fundamentally, you are paying for the server that comes with that memory, right? So you go look at the costs that you would see up on Amazon or Google or Microsoft or IBM, and they're going to say, here's your large instance, and that's your cost for that amount of memory. And that's going to vary, obviously. And on top of that, it makes a lot of sense to go with the largest instance if you need that much, okay? But that's basically how much you're going to pay. And disk is really cheap, right? So you're clearly going to be paying more to put it in memory. And that's going to come up, I don't know how to calculate for you. Everyone's a little bit different.
You haven't heard any numbers from Netflix, Facebook?
Oh, for Netflix? No, I have not. I don't have any formula. I don't know if they share that. Okay, I guess there's a lot of questions.
You mentioned OpenShift integration, so is that on-premise or off-premise? And can you talk a little more about that?
Yeah, sure. So for those of you who don't know, OpenShift is a platform as a service software, but they also run it as a service at OpenShift.com. Okay, kind of like Heroku or something like that. Now, we have a live integration with OpenShift.com. We did have an integration with OpenShift, the software, but they've changed that recently. Now they're using Kubernetes as the baseline, and we haven't completed our Kubernetes integration yet. So we haven't updated our integration with OpenShift to work with on-prem. but that is on our list of to-dos. And for those of you who don't know, Kubernetes is a very interesting platform as a service software. I wouldn't call it platform as a service, but maybe like the bottom half of platform as a service is scheduling software.
Container management.
Yeah, container management, and it's very interesting. And so we definitely will be supporting that. And once we support that, then it's very little extra effort to support OpenShift on what do we call it? OpenShift Enterprise, I think is what we call it.
Last question.
If you're interested in that, please follow up with me, and I'll
Okay, great.
let you know as soon as we have that. Yeah.
Can you talk a little bit about the multi-data center? I know the Redis Lab is one of the features trying to resolve this seamless failover, and then you do the data replication. Can you talk a little bit more about that?
Yeah, so those are two separate problems, right? Failover versus real-time replication are similar but different. And basically what he's asking about is, if you're dealing with data in real time, Redis has a mechanism. You can basically have a replication, or some people call it master slave, where you can have your data replicated to another instance, right? Now Redis doesn't do master to master, okay? It only goes, replicates out to the slaves. So from the master, the other instance could be in the same data center, and in that case, that's not much of a problem. Open source does that quite well. Where you run into trouble is when your other instance is in another data center somewhere. And so that is difficult to deal with, and I don't think that open source has solved that problem yet. We kind of have. Now, I only say kind of because I haven't done it myself, but I know that we have a WLAN integration that has like basically region to region replication, and there's like all sorts of complications that go on with this, folks. Like, it's seriously complicated because you send a update and you don't hear back, so you send another update. Well, in the meantime, it actually did get through, and so there's like all sorts of deduping that has to go on. There's all sorts of things that have to happen to make this work. And so we've done that, and so we can now do replication from data center to data center or region to region.
Okay, that's all the time we have for questions right now, but Dave Nielsen will be here for one-on-one questions right after we are done, which will involve giving away the rest of these shirts and giving away a Star Wars geek toy. Star Wars, Star Trek? Star Wars geek toy. Can someone tell me where the fishbowl is?
Right here.
It's right here? Okay. All right. Can I ask you, just mix it up?
I've like watched every Star Wars trailer like 10 times. I cannot wait for them out.
Can I ask you to reach in, look the other direction, and pull out a card? And then say it. So say what's on it, excuse me.
Logan Best. Logan?
Logan Best?
Uh-huh.
You got it.
The winner.
Thank you all for coming. Feel free to come up and help yourselves with the shirts.
I'll stick around. We got shirts. I'll take your questions. Thank you very much for having us, folks.